In this video, we're going to look at the hydrolysis of a nitrile in first in base and then in acid. These reactions all go through amides, and so we'll see some familiar things. So let's start by attacking the nitrile here, or the hydroxide, which will attack the carbon and push electrons out onto the nitrogen, very similar to the way it would attack a carbonyl. So this will give us a strange-looking species, which is kind of it requires basically an enol tautomerization, except of course it has a nitrogen in here. And so the double bond is going to reach out and grab that proton, and those electrons will then form the carbonyl. So this will give us essentially a deprotonated amide. And this deprotonated amide is basic enough to pick up a proton from the water. So we'll bring a water molecule over here, and this will give us our amide. And the amide then undergoes just kind of normal hydrolysis, which of course we're all familiar with now. The hydroxide comes and attacks the carbonyl oxygen. So I mean, look at the parallel between this original step and this one. And basically the same thing going on here. And this is a step that's a little bit tricky, because what we want to do, of course, is to restore the carbonyl and push out the amide, but that nitrogen doesn't really want to be around without a proton. So at the same time, we'll go pick up the proton here and restore that to carbonyl. So this is going to give us our carboxylate and our amine. So that's the hydroxyl catalyzed reaction. So let's go back and reload, and we'll do the same thing with acid. So now with acid, got to change this to acid. We're again going to do something similar to what we did just with the amide, because the first thing now is, now of course not, in the case of an amide, we protonate the oxygen. Now we're going to protonate the nitrogen. And so this is our first step. Okay. Again, we'll have a water molecule attack. Here's our water molecule. This is going to come around and attack. Push the electrons out onto the nitrogen. And now we have this strange-looking species, and it will do something similar as before. Is we're going to have the double bond here reach out and grab the proton. The proton electrons will form the carbonyl, and we have our amide. It's protonated amide, and that of course then can be attacked by the water. We're already off and running. Okay, and so attack carbonyl, electrons out onto the oxygen. This gives us our tetrahedral intermediate. Sorry. And now we can do a proton transfer within the molecule. Grab one of those protons and get our amine all set up for leaving. So now we have a good leaving group on there. We'll just take one of those OHs, bring it back to form the carbonyl, kick out the amine, and there's our protonated product, and then this nitrogen can pull off that extra proton, and we're in acid. So this ammonium carboxylic acid combination is what we'd expect. So we get our carboxylic acid and the ammonium ion. So that's the hydrolysis of the nitrile. It's a little bit complicated, but if you know the amide, you know the hard part.